Okay, problem number 19. List two primes that are consecutive natural numbers. Well, if you look at the list of prime numbers, we start out with 2, 3, 5, 7, 11, 13, 17, 19, 23, etc. And so the only two prime numbers that are consecutive are 2 and 3. And can there be any others? Well, there's no, it cannot be, because you cannot have an even, the only even prime number is 2. So no even primes except 2. So as a consequence, you can't have consecutive numbers, because one's going to be odd, one's going to be even. So the answer is no. Okay, 22. Consider the divisibility test for 2, 4, and 8, all powers of 2. Use inductive reasoning to predict the divisibility test for 16. Then use the test to show that 456,882,320 is divisible by 16. Okay, so what's the test for 2? It says the number has to end in 0, 2, 4, 6, or 8. So it has to be an even number. 4 says the last two digits form a number divisible by 4. So it has to be divisible by 4. 8, the last number has to be divisible by 8. Actually says the last two digits. So this one's 2 digits. And this one is 3 digits. 3 digits. So you'd say 16 has to be divided by 16, and it has to be 4 digits. Why is that? Well, if you think about it, this one is, if you take 100 and divide by 4, you get 25. So any multiple of 100, anything in the hundreds place can be divided by 4. Now, if you have this, if you have it, so this is divisible by 2, 1 digit, divisible by 4, 2 digits, divisible by 8, 3 digits, divisible by 16, 4 digits. So we have to look at this big long number, but all we have to do is worry about the final 4. Anyway, this is if you can divide 1,000 by 8. And you can divide 10,000 by 16. So that's, but you can't divide 1,000 by 16, I don't think. 1,000 divided by 16, and you get 62.5, so that doesn't work. But you can divide 1,000 by 8. You get 125. And if you take 10,000, you divide by 16, you get 625. So that's the way it works. So when we look at our number, which is, this is problem number 22, 456,000, 1,822,320. All we have to do is look at 3, 2, 0. We have to divide that by 16. So let's do it. Rather than using our calculator, let's do it the long way. So we get 1, 16. That is 7. 13 minus 6 is 7. Carry bar 1, you get 0. So we carry this down to 6 times 6 is, actually that's not what I want to do. So how many 16s go in there? Well, 5 is going to be 5 times, it's going to be 80. So really there's only 4 going to work. 4 times is 24. 2 times 2 added to 4 is 6, so we get 8. And then 5. There are 5 16s and 80, so you multiply 5 by 6, you get 30. Add 3 to 8, you get 3 to 5, you get 8. There's 0 remainder. So this is divisible. 2320 is divisible by 16, and therefore it's divisible by 16. Okay. That's our next problem. 25. Find the prime factorization for each composite number. So we have 168. So there's a couple of ways of doing it. I'll use this one where you kind of divide stuff out. What's it called? Prime factorization tree. So what we do is we look for an even number. If it's even, we divide by 2. So 168 divided by 2 is going to be equal to 84. Is that an even number? Yes. Okay, so it's divisible by 2. 84 divided by 2 is 42. Still an even number, so we can divide by 2 again. And we get 21. Now it's odd, so we can't divide by 2, so let's go to 3. Can you divide 21 by 3? Yes. What's the result? 7. 7 is a prime number, so now we have our prime factorization. So, and then we have 3 2's, so we can say 168 is equal to 2, and we have 3 2's, so we raise it to the third power, times 3 to the first power, times 7 to the first power. And we don't have to explicitly put the first power in this, so we just 2 cubed times 3 times 7. Okay, the next problem is 28. And we have 931. So it can't divide by 2 because it's an odd number. Can we divide by 3? Well, if we add these numbers together with 13, 9 plus 3 is 12, plus 1 is 13. That's not divisible by 3, so we can't divide it by 3. All the even numbers are out of it. 5 we can't do. 7. Let's try 7. So we're just going to try 7. 931 divided by 7. 931 divided by 7. We get 133. So here's 1 prime, 7. What we have left is 133. Again, if this one's not divisible by 3, then this isn't divisible by 3. So you can kind of go to the next number. Let's try 7 again. 133 divided by 7 is 19. Okay, so that worked out pretty good. So we have 7. The result is 19. Is that a prime number? Yes. So that's our prime factorization. So we can say 931 is 7. We got 2 of those, so we square it times 19 to the first power. We'll just write it as 19. So 931 is 7 times 7 times 19. Okay, 28, 29. 29 uses, okay, we have a new divisibility test to determine whether each number is divisible by 7. So let's write the number down and then read the rules. So we have 214,256. Double the last number, double the last digit of the given number. So that's 12. Taking this number. Double the last digit of the given number and subtract this value from the given number with the last digit omitted. So if we take the last digit omitted and we subtract 12 from that, we'll get that. Repeat the process of part A as many times as necessary until it is clear whether the number obtained is divisible by 7. If the final number obtained is divisible by 7, then the given number is also divisible by 7. If the final number is not divisible by 7, then neither is the given number. It's interesting. I have to think about that for a second. Let me make sure. Double the last digit of the given number and subtract this value from the given number with the last digit. Oh, with the last digit omitted. I forgot that part. So assuming that goes to, well, I guess actually I think what it means is this. So you subtract 12 from that. So that's 3, 1, 4, 1, 2. Okay, now take the last digit, multiply by 2, get 6. Then you take the number, omit the last digit, subtract 6. So then you get 6, 3, 1, 2. Take the last digit, which is 6, times 2, which is 12. Take this number, subtract 12, and we get 201. Take the last digit, which is 1, times 2, which is 2. Subtract this from the last digit. Remove that, subtract, and we get 18, which is not divisible by 7. So apparently I've done something wrong. So let me look here in the book and see what I'm supposed to do. So we take 21, that's correct. What's that? Gives us that. We take 2140. Oh, this is 41. $41, 21401. That's the one I'm supposed to do. Okay, so we do that, and we'll get 35. 2135. Okay. And so 2135, we take 5, which is the remaining thing here. Multiply by 2, we get 10. We subtract 10 from that. So that's 2003, 203. Okay, we have the last digit is 3. So 3 times 2 is 6. So then we have 20 minus 6 is 14. 14 is divisible by 7. So since 14 divided by 7 is equal to 2, and we get a whole number, it is divisible by 7. Okay, so I think we're going to do another example because that's a fairly complicated expression or procedure, but now that I understand it, 32 is 325951. Last digit, 1 times 2 is 2. We take 32595, subtract 2. That leaves us 32593. The last digit is 3. 3 times 2 is 6. We take 3259 minus 6, and we get 3523. The last digit is 3. Multiply that by 2, we get 6. We take 325 minus 6, and we get 319. We take 9 times 2, which is 18. Take the last two digits, or the last two, minus 18, and we get 13. 13 is not divisible by 7, so 13 divided by 7 does not equal a whole number, and so the original number, which was 3259251, is not divisible by 7. Okay, so that's that. Now let's try the next one, which is 33. So we're going to do 2 of these as well because it's a different. So we're trying to find the divisibility test for 11. Starting at the left of the given number, add together every other digit. Add together the remaining digits. Subtract the smaller of the two sums from the larger. If the final number obtained is divisible by 11, then the given number is also divisible by 11. If the final number is not divisible by 11, then neither is the given number. Okay, so we got 6,524,846. So stop for just a second. Okay, so I'm back. Just had to talk to my neighbor here. So let's try it, see if we can do this without cheating now. Okay, start at the left of the given number. Add together every other digit. So 6 plus 2 plus 8 plus 6. 6, 2, 8, 6. That's 8 plus 8 is 16 plus 22. Add together the remaining digits. 5 plus 4 plus 4 is 9 plus that's 13. Okay. Subtract the smaller of the two sums from the larger. 22 minus 13 is equal to 9. If the final number obtained is divisible by 11, then the given number is also divisible by 11. If the final number is not divisible by 11, then neither is the given number. So since 9 is not divisible by 11, it's not divisible by 11. Okay, the second problem is 36. Make sure this is, well, actually we're going to choose 35. 34. We're going to do 34 because 35 is an odd number, so I have an even number here. And this one is divisible, so I know this didn't work out, so let's see if it worked out or not. So it's 108,410,313. Okay, so we're going to take 1 plus 8 plus 1 plus 3 plus 3. 8, 1, 3, 3. 10, 16. Take the other numbers, 0 plus 4 plus 0 plus 1, which is 5. Subtract the smaller from the larger, we get 11. 11 is divisible by 11, so it is divisible by 11. Okay, how many have we done here so far? Okay, I think that's enough for right now. We'll start a next thing coming up here. So the last one we did was 34.